Alright guys, we're going to do 1-16 proofs involving definitions of square-like things. So what we're hoping is going to happen, we're going to be chasing away these triangles with these square-like things. Let's see if that's actually going to happen. Okay, so let's look at the first example here. The first example, right, says that we're given a parallelogram, right, and we want to prove that the opposite sides, right, AB is congruent to CD and BC is congruent to AD. We want to prove that they're congruent, okay? So we're going to prove that opposite sides are congruent. So a little factoid about this, all right, parallelogram, opposite sides being parallel, that's the definition. All right, so this being parallel to this and that being parallel to that, that's by definition. What we're actually going to prove here is the property of parallelograms. All right, so that's one of their characteristics. That's a property. Okay, so let's take a look at a parallelogram. Okay, so here's our evil parallelogram, and we're going to take a quick look at it. So what we got here is that this guy here is about 80 degrees. Okay, then I turn it. And you notice that this is about 80 degrees. Okay, those are those alternate interior angles that we've come to know so well. All right, watch what happens now. If I cut our evil parallelogram in half. All right, I'm going to do my best to make a split triangle here. Okay, slow death for our parallelogram. Alright, not so evil anymore. Alright, so let's take a look now. So as a result, when I take this guy and I break him into half, right, let's take a look at his angles. So if I go like this and I measure it, that's 30 degrees, right? I'm going to do it here too. Right, it must be like that. Nope, he's definitely like this. Okay, it's a little bit off because of the way I cut it, but you can see that they're pretty close together. In fact, right, I cut it in half, and we have almost two congruent triangles, right? So my point there is that in the end, even though we have parallelograms, we're still proving the triangles are congruent. Okay, so let's do that, right? Inside parallel lines, we always have alternate interior angles. So let's mark those off, okay? And the reason why that's happening is because these are parallel. So I have to point that out. So first thing I'm going to do, and this is the second line on your sheet that says definition of parallelograms, I'm going to say that DC is parallel to AB. And I'm going to say that AD is parallel to CB. And that's because of definition of parallelograms. If you want to write that ABCD, it's because ABCD is a parallelogram, that works too. Now, inside there, right, we said we have the alternate interior angles. So I'm going to say angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, and that's because they're alternate interior angles. Notice that I pointed out the parallel lines first, then I pointed out the alternate interior angles. We cannot have alternate interior angles without the parallel lines. Now we go to our classic stuff that we know. I have my shared side here. So AC is congruent to AC, and that's because it's a shared side. So my triangles are congruent because of, let's see, angle, side, angle, angle, side, angle. There it is. All right, so triangle ADC is congruent to triangle ABC. And that's because of angle, side, angle. Now I can make this statement, which is the property of a parallelogram, right? We're proving a property of a parallelogram here by saying that this is true because the triangles are congruent. So I'm going to say because the triangles are congruent. All right? All right, let's take a look at the next example. So the next example works slightly differently. All right, what we have this time is we have a bunch of pieces and we want to prove that the triangle, this thing here is a parallelogram. Now, let's work backwards, okay? We're going to work backwards on this. So we're going to say that in order to have a parallelogram, I need to have parallel lines, right? In order to have parallel lines, I need to have alternate interior angles, right? Now, what I can do is I can prove that these two triangles are the same. Then I could say whatever angles are congruent that I want. So that's where I'm going to start. So it says here that, I'm going to start with the green here. It says here that AB is parallel to CD. And it tells me that AB is parallel to CD. So I'm sorry, AB is congruent to CD and AB is parallel to CD. So now that I know that these are parallel as well, right, I'm going to say that this and this are congruent because they're alternate interior angles. Then I have my shared side here. All right, so let's write that up. So I have angle 1 is congruent to angle 2 because they're alternate interior angles. I'll write it out. Alternate interior angles. Now, I have the shared side there. So AC is congruent to AC, and that's because it's a shared side. Okay? And I can say that my triangles are congruent because of side, angle, side. So, triangle ADC is congruent to triangle ABC because of side, angle, side. All right? Now I got that done. So now what I need to do is I need to prove that these are parallelograms. Well, before I stated that if we have alternate interior angles going all the way around, I know that opposite sides are congruent. Notice I only marked these, right? That's because I don't have the parallel lines here. I don't have that going on. So I'm going to mark those off. I can mark them off now because of this. So I'm going to say that angle 3 is congruent to angle 4 because of the triangles are congruent. Okay? Now, right, you're going to have this line here that says inverse of alternate interior angles. Basically what that's saying is that AD and BC, I'm going to say that they're parallel. Okay? I'm going to say now that AD is parallel to BC. And I'm saying that because of that. That's what that inverse of alternate interior angles means. So I'm going to say because angle 3 is congruent to angle 4. Okay? Now, I have my set of parallel lines, my opposite parallel lines. So now I can finish my statement by saying that A, B, C, D is a parallelogram, and that's because AD is parallel to BC and AB is parallel to CD. Okay, so now that I have opposite sides being parallel, I could say that. All right, so it's just thinking backwards. All right, guys. I hope you guys found this video helpful.